So again, this is this is a definition of what? Of the nodal voltage and the voltage difference. Nodal voltage and the voltage difference. So the voltage difference is the difference between this point and this point. So VA is the voltage at A. VB is the voltage at B. But VAB is the difference between A and B. Here, example, assumes that you have this point A and this point B. Okay? The difference between them assumes that the element is connected between A and B on this line here, like this. You have element like this, resistor, whatever here. Okay? What is the difference in this case? The voltage here is 15. The voltage here is 15. Then the difference is 0. Okay? Then in this case, you cannot expect current. But assume that you connect element here on this line, like this. Okay, so now the difference is what? Is 15 in this side, 10 is this side, so the difference is 5. If you connect element on this line, so in this case, the difference is what? 15 from A, side A, and 5 in B. Then it will be 15 minus 5 will be 10 volt, and so on. So you expect current if the element is here. You expect current if your element is here, but you do not expect current if the element is here. Why? Because the voltage is different. Is the same. The voltage here is the same, 15 and 15. There's no difference. Okay, so this is the voltage difference. Second, here is the current. As I said before, the current, we must have charges moving. We must have charges moving. But exactly, the electric current is not just charges. It is the time rate change of current. Time rate change of moving charges. Time rate change of moving charges. So we explain this mathematically like this. It is dq by dt. dq by dt. And the unit is in ampere. I forgot to tell you that the voltage in volts. I don't know if I can remember if I said that or not. But the voltage is in volts. Very easy. The unit of voltage is volts. The unit of current is ampere. And here, imagine that you have element like this, and it is connected to battery. And this is high voltage. This is low voltage. Okay, so this is positive. This is negative. What happened here? That this positive will make this terminal positive. Okay, so if you have a positive here, this means that there will be a repulsion force between the positive voltage here and the positive charges here, which makes these charges moving from left to right to the negative terminal, and then the positive charges are moving like this, and then it will return, go through the battery, and then continue like this, and this what will create the current. The current is moving from where to where? From the high voltage, which is the positive, to the low voltage, as I explained before. So again, in this example, if I assume that the element is here, then this side is 15, this side is 15, there's no difference in voltage, then you do not expect any current here. But if the element is on this line, okay, then what happened? That you will have 15 and 10, then there's a 5 volt difference, then the current will move from the high to the low. If the element is here, on this one here, for example, so this is 15, this is 0, then there's a 15 volt difference, the current will move from the high to the low. If the element is on this green, dotted green, for example, okay, then this side is 15, this side is 5. The difference is 10 volt. Then the current will move from the 15 to the 5 volt. Okay. Voltage or current, both of them are either DC or AC. So DC and AC are not only for voltage or current. The current or voltage can be AC or DC. What's the meaning of DC or AC? Very simple. DC is just constant value. AC is variable. You see this sine wave? This is the AC. That's it. And there are many examples of DC and AC. So DC means constant. AC means variable. Let's see some examples of DC and AC. Here is AC. Okay, so the AC is the power you get from the wall. Usually, when if you know that, I believe that the power you get from the wall is 110. But I said that it's AC. AC means variable. So what is this 110? Okay, 110 is the root mean square value of the sine wave. Root mean square value of the sine wave. So it is not that 110 constant. No, it is a sine wave, and its root mean square value is 110, which means that the maximum of this sine wave is 110 times square root of 2. Usually it is like this. You can also generate AC using alternator. Also you can do that. DC, you have many sources of DC. Like for example, this battery. This is a car battery, you know this. It's 12 volt. Or for example, you can get the battery voltage from inside the car. Okay, when you the voltage here from the car is 12 volt, but remember sometimes you can see that it's 5 volt. It's not a 5 volt. When you, for example, if you want to charge it, to use it as a charger for the cell phone, you have an adapter. This adapter will convert this 12 volt to 5 volt to be able to charge your cell phone. Or for example, sometimes you can use it for other applications, like for example, if you have a GPS or whatever, any other stuff that you can use this for. There are many kind of batteries. All this, you know, these batteries, you can get it from anywhere. Like this one is 3.7, this one is 9 volt, this one is just maybe this for a watch, for example, and so on. So these are all different batteries, and they are example of DC voltages. DC voltages. Of course, there is no DC current. There is no source that you can see from this. There is nothing here. All of these are DC voltages, not DC currents.